All right, well, I want to welcome everyone to the Pretty Good House. Before we get started, I want to thank one of our top tier sponsors, Aware. This device tracks 5 key indoor air quality metrics in real time down to 5-minute intervals and will communicate when issues arise and what the severity of those issues are. It tracks things like PM 2.5, which may result from cooking, traffic, or as I've personally recently learned, some wildfire smoke blew over from California and polluted my house in the middle of the night. Or a neighbor was burning in the wintertime and polluting the entire area. Very nasty stuff. I got to learn that. We also saw total volatile organic compounds get changed from certain things we do in the house, got to learn about candles and other chemicals we're using and what to get rid of. CO2, which, believe it or not, it's not just bad in the atmosphere, but too much of it in our homes make us groggy, sleepy, irritable, and somehow also ruins sleep at the same time. Humidity, very important, right? We want to keep that right in the middle. And of course, temperature, which helps you know dew point when you're tracking humidity and other things. And so you can track this data over time, over the course of the day. When spikes are occurring, what's going on. You can track it over large amounts of time as well on each of these features and try to get a sense for what's going on in your house or in your clients' homes. And they also have the new Aware Omni, and we're challenging all builders and all architects to leave behind one of these devices in your projects and set it up for your clients and prove that you're building healthier as well and help them navigate that. These devices are reset certified to ensure proper air quality, and we encourage you to check it out over at getaware.com. Also, thanks to our second tier sponsors, who's been named Green Builder Media Eco Award Leader of 2022, Niagara Conservation. Just toilets use the most water, and it's just a simple flush away to cut that water usage. We've got this big multifamily project they just showcased, 375% return on investment after switching over to stealth technology, 0.8 gallons per flush. I swear to you, I installed one in a 1926 home. Never had any issues. We've got glowing reviews on them. Check them out at Niagara Conservation. All right, again, welcome to our session, The Pretty Good House. The session is brought to you by the Green Home Institute. Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. My name is Brett Little. I am the education manager here at the nonprofit, the Green Home Institute. This course is approved for multiple continuing education units, among them being the AIA Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license, and all 5 pillars of green energy, health, materials, water, and place. So with that, I am super excited to start the New Year's off right with our first webinar of the year and hand it off to our speakers here, Emily and Mike. They're going to introduce themselves and the concept of the Pretty Good House. I'm here to learn just as well as you, and we'll get to some of your questions. So Mike, Emily, welcome, and please take it away.
Hello, Brett. Thank you for inviting us today. Really appreciate it. I'm Mike Maines. I'm a residential designer in Maine, former builder with an engineering degree. I've done some building science consulting, some writing for Fine Home Building, and along with Emily, co-wrote the Pretty Good House book, and we also co-host the BS and Beer show. How about you, Emily?
I'm an architect in Maine. I have a podcast as well. I do a monthly podcast on energy efficiency and being a female entrepreneur in this industry. And as Mike said, we co-wrote a book. We co-host a BS and Beer show. We do a lot of things, just trying to spread the BS around.
Yeah, and today we're going to I'll start out with sort of explaining how Pretty Good House started and the basic tenets. Emily will present a case study, one of her projects that's sort of an ideal Pretty Good House. And as much as possible, if we can save questions until the end in terms of answering, but if there's anything urgent, we can certainly jump in and answer those as we go. So what is Pretty Good House? It's a it's a crowdsourced grassroots movement. We actually don't have any rigid rules. Fundamentally, it's just a way to think about what is important when designing and building a high quality home. We have distilled the concept down into these key principles, which we'll explain in more detail. But just to read through them quickly, the Pretty Good House principles include considering the house as a system, building no larger than necessary, build simply, make energy improvements until they stop making sense, prioritize good indoor air quality, support your local economy, support local and global ecosystems, build durable, resilient homes, and design homes with aesthetic appeal. I promise this presentation will not all be just reading what's on the slides, but there will be a little bit of that. Pretty Good House is definitely not the only program. Of course, we hadn't had many come before us. Some of the more popular ones I'm sure you're aware of are Lead for Homes, Energy Star, Passive House, Living Building Challenge, Department of Energy, Zero Energy Ready Homes, or Green Home Institute's Green Star program. These are all excellent programs. They're all doing good for the market. Even code minimum is even getting pretty good, but none of them are solving all of the problems we have. Not all of them think holistically. Not all of them have great market penetration. So we're just sort of providing one more way of thinking about how to build better homes. It started at the original building science discussion group at Performance Building Supply in Portland, Maine, a little over 10 years ago. Our moderator, Dan Colbert, was working on his second, I think, Lead for Homes project. A lot of us were getting into Passive House and learning about just how much insulation you need to meet the Passive House requirements in cold climates. Especially 10 years ago, we were using ridiculous amounts of foam to get there. And we all had trouble getting client buy-in. So Dan just asked us to brainstorm some ideas on how we should really build our houses. We also brainstormed names and settled on what Dan had originally figured as a title of Pretty Good House. There's a lot of the Pretty Good House that overlaps with other programs and a few things that are unique. Some of the more unique aspects are economics. Of all the programs out there, few or none consider the client's budget, and whereas in doing over 600 projects, I've never had one yet that didn't have a budget. So if pretty much every project has a budget, why aren't budgets considered in the green programs? We focus on lower embodied carbon or carbon sequestering with the climate crisis. That's really important, and we'll show a slide that explains more. And then it's a team approach. We're concerned not just with the end result, but how we get there, and how we get there is not necessarily from the traditional, design, bid, build arrangement. We really prefer a team approach that gets everybody on the same side of the table. Speaking of team approach, here's our three-legged stool of the three most important team members. There's the design leg, the construction leg, and then the client leg. The clients are also responsible for funding, and one person or entity may serve more than one of these roles, or each role may be served by multiple people depending on the size of the project. But you need all three of these working in concert for any successful project. You can't be adversarial about it. We also want people to consider climate. Just where you build really makes a big difference for lots of reasons. So understanding not just things like heating degree days, but what is your humidity load, what are your dew points, what are local conditions, wind zones, pest pressure, all those things matter. And then infrastructure and regulatory constraints, and things that drive things like natural disasters. Essentially understand the things that are important before you start designing. Oh, and I should have mentioned these overviews are basically follow the chapters of our book. This is all just a very abbreviated overview. We go into more detail of all this in the book, but we're really not here to sell our book. We're here to explain the pretty good house concept, and there are multiple ways to learn more. So one of those other important things that we like to consider is economics. While on one hand, you could say the most affordable and sustainable home is the one you never build, we do encourage renovations and remodeling and not building at all when possible. The fact is, we are going to continue building houses, so let's do it in the most economical way we can. Building a custom single-family home is inherently expensive, and it's really a luxury. So it's worth taking the steps to do it right. And sometimes the economics just plain don't work. We did brainstorm at our initial meetings, and we've revisited and in multiple online locations. We've discussed how big should a pretty good house be, and there's definitely no one size fits all situation, but we do tend to try to keep things on the smaller side because it really has wide ranging results, from lower material use, lower embodied carbon, less energy required for operations. It does require better, it requires more attention put into the design in order to make a small space feel like a bigger space. But if you can get 4 people into 1,800 square feet comfortably and have it live like a 2,600 or 3,000 square foot house, then you've really done something good. One of the important elements of a pretty good house is design, and that shows up in lots of ways. This is basically everything you expect a designer or architect to do. So not necessarily the energy end of things or the mechanical end of things, but the aesthetic design. How complicated is the building? This is an example of an attractive house built on the Maine coast. Very beautiful. Lots of details, lots of opportunities for energy leaks, lots of opportunities for ice dams and snow buildup. There's a shed roof leading into that tower. I can just imagine what the window flashing is like. So as beautiful as this is, a lot of money, time, effort, carbon is going to just maintaining the envelope, where if it was simpler, it would be a lot easier to build, a lot easier to operate. And design also includes things like where is the house on the site? What site is the house on? Where are the views? How's the sun entering? What is the wind doing? All those things are important aspects of design. And we like to say that the house needs to be loved in order to be maintained. So if you build something that's incredibly unique that you love but nobody else loves, then it will get torn down when you're done, and it's a net loss on the environment. We do go into basic building science. So the building envelope is obviously very important. You look kind of ridiculous showing up in Maine or Michigan for a winter hike with just a hoodie and jeans. If you're into outdoorsy stuff, you know how ridiculous that would be, just not appropriate for the environment. But that's how most of our homes are built. A pretty good house should have an exterior building envelope that's appropriate for the climate in which it's built. In Maine, that's basically the equivalent of a parka. We follow Building Science Corp's recommendations for high performance homes of R10 under a slab, R20 foundation walls, R40 above grade walls, R60 in the roof. That's a good starting point. Although with energy modeling, you can change that. Other climates will have different recommended levels of insulation. And we really think about things in terms of control layers. So we have in order of importance, the most important is the WRB, the weather control layer or rain control layer. Air control is the next most important. Vapor control is important. And once you have all those solved, thermal control is the next most important. We often lead with thermal control. It definitely is important, but until you have the other control layers right, you shouldn't prioritize thermal control.
Mike,
Yeah.
do you have recommendations? Like, do you try to follow like the IECC, for some of these recommendations, especially since they seem to be kind of climate specific?
Yeah, essentially as a starting point, we recommend back in 2011, Joe Stiebrick and Building Science Corp issued a paper on high performance building assemblies or thresholds or something. I forget exactly what it's called, but essentially they went through each climate zone and said you need roughly this amount of insulation is the threshold that sort of balances performance and economics and that kind of thing. In the book, we basically recreated those. I think we made some adjustments just to make things look better because it's really not important. Like if your walls are R30 or R32, that's not important. So if it's around R30 versus around R20, that's important. So for new construction, that's where we start, but we do recommend energy modeling. I often find R40 walls, depending on the assembly, if it's a double stud wall with cellulose, R40 makes sense. If it's a wall assembly that includes foam, then it probably makes sense to be more like R30.
For anybody that has the book, page 86, there's a how much insulation do you really need chart that's based off of what Mike's talking about. So for anybody who has a copy of the book already, it's in there. Well, can't see it. Makes me disappear with my background.
Yeah.
Just as a starting point. And then there's also to add on what Mike was saying about, or your question about the IRC and the IECC, we encourage people to try to do at least whatever the most current one available is. So start with 2021 as your recommendations, because that's what's most currently available. And then you also use the IRC sections 702 and 802, I think, to determine condensation resistance. But that's a larger answer to a question.
Thank you.
Yeah, absolutely. And then specific control layers of water and moisture management are extra important, especially in a pretty good house or any high performance building assembly, because assemblies that have a lot of insulation have less heat energy to push moisture through, so they're more vulnerable to mistakes. It doesn't mean we shouldn't be building high performance assemblies. It just means we need to really understand what's happening with water in all of its forms. So we recommend high quality WRBs. We usually recommend variable permeance interior membranes. We strongly recommend rain screens whenever possible. This example, we call it a basket house. It's strapped 5 inches on center to receive exterior locally sawn white cedar shingles. And we also have to consider vapor control, not just storm water, but water vapor. In cold climates, we're worried about what happens from interior vapor getting out. In hot climates, it's more about exterior vapor getting in. Vapor is much less of a problem than bulk water, especially once things are airtight, but it can still add up and become a problem if you don't have good assemblies. Basically, what water is the enemy. So understand what's happening with it. So of all those control layers, you may not have thought about it this way, but windows and doors actually perform the functions of all 4 control layers. Meanwhile, they have to open and close multiple times a day. And we also expect them to provide heat and keep out and allow us to have good views, yet keep out glare and extra heat. So they really are doing a heck of a lot, and they're expensive and will be installed for a long time. So we recommend putting extra effort into designing a good fenestration system and buying the best ones you can afford. You want to consider the U factor, which of course is the heat flow, the solar heat gain coefficient, which is how much energy it's letting in, visible transmittance, which is how tinted is the window basically, condensation resistance, and design pressure rating. Those are all important numbers to understand if you're designing and building a house. This is one of my favorite slides or parts of the book, the materials. So, what is the global and what is the local and global impact of the materials we use? How is it going to be for the installers in terms of health? How will it be to live with? Does it take a lot of maintenance? Will it age gracefully? Is it repairable? Those are all important things. And if you look at the top right, the chart, triangle chart shows embodied carbon versus operating carbon. So operating carbon is the orange part. That's what starts accumulating once you move in. It's the results of the energy required to keep our houses heated and cooled and operating. Embodied carbon or upfront carbon emissions is what's involved in the materials we use, and so that is pretty much all spent on the day you move in. So over the course of 100 years, obviously operating carbon dwarfs embodied carbon. So traditionally in green building, we're more concerned with the operating carbon emissions. How low can we get them? But with the climate crisis, we really only have a decade or so to get things under control. So if you take a snapshot of that graph and just look at the 10-year time frame, you can see that embodied carbon actually matters a lot more than operating carbon in the short term. So that's where I've been asking about like wall assemblies. If you're using foam typically has high levels of embodied carbon. We would recommend keeping it on the lower end. And sacrificing operating carbon emissions in the interest of keeping embodied carbon emissions low. If you're insulating your walls with a carbon sequestering material such as wood fiber insulation, we would recommend putting as much in as you possibly can afford. Moving on, mechanical systems. Obviously, every house has a mechanical system. We really try to think of the whole house as a system. Because if you change one thing, it affects something else. And so the mechanical system should be custom designed for each project with an accurate manual J, manual S, manual D if necessary, if you have ductwork, and just understand how all the parts and pieces interrelate. We talk about electricity and lighting. We do recommend preparing your house for PV panels, either roof mounted or ground mounted if possible, although there are community solar options in most places that are becoming more attractive. So as long as you're creating energy in a renewable fashion, that's what's important. We also want to minimize electricity use. We want all electric homes as much as possible. Don't burn fossil fuels on site if you don't have to. Don't even burn biomass if you don't have to. That one's a little more contentious in warm climates with a long history of heating with firewood. But it can be good for backup heat and resilience. And use LED and understand good lighting principles. Lighting is often pretty poorly done. You end up with too much light and it being and it's uncomfortable. We did 2 BS and Beer shows with David Warfel on lighting, and really I learned a lot about modern lighting. It's not the same as designing lighting was 20 years ago. There's a whole new approach that gives you good quality while minimizing carbon emissions. Emily might have to help me out here because she's a HERS rater and does a lot more of this than I do, but we do strongly recommend client verification and education, although we don't have a central body that a lot of other programs such as Passive House has for ensuring that your house is built the way it's supposed to be built. We do recommend monitoring using an Aware or other device. to measure things like PM 2.5 and CO2 and total VOCs and relative humidity. Those are all important numbers to know and understand. We recommend, blower door testing at multiple stages, infrared camera use if possible, commissioning systems, so the mechanical systems are actually operating the way they're supposed to. And then we really recommend leaving clients with some sort of handbook or manual. If you think about it, every product you buy has a manual, like if you buy a toaster oven as a manual. Yet our houses, which are by far the biggest, most complicated, most expensive things we have, full of products, usually don't come with a manual on how to operate it. In the past, houses could be operated more or less intuitively. The more complicated they get and the more options are out there, the less intuitive it is. So you really need to leave your client with a good level of education. Did I cover it okay, Emily? Was there any? Oh, you're muted. You're muted.
Sorry, I was trying to answer a question. No, I thought you did good.
Okay.
I think is what I would have said.
Okay, good. So that's the end of that section. We did write a book, like we said. If you want to learn more, here's a code on that cuts the price by something like 25%. The authors are Emily and me, and plus another architect, and plus a builder, Dan Colbert. And we try to provide basically guidelines that work anywhere in the U.S. If you want more hands-on training, Emily is doing basically the Pretty Good House training program is called the Sustainable Home Building Accelerator through Taunton. So here's a code for that. And that starts next week, Emily?
It is going to start. I'm not sure if the first course is going to open on the 4th. They might push it back to the 9th, but it's going to start soon.
Okay. And we have a website. So basically the things we talked about today, if you want a little more information, but don't want to buy the book or take Emily's course, there's a lot of information on our website, brief descriptions of each chapter, plus lots of links to other resources. And Emily and I do the BS and Beer show, which is a free online discussion every month to talk about building science topics. And we have, 100 and something past shows available on YouTube, which you can get to through bsandbeer.org. And that is the end of my portion. I will turn it over to Emily to do present the case study.
Okay. Sorry, I was trying to answer as many questions as I could on there.
I'll switch you. I'll jump onto question duty since I can't do your case study.
Wow. We like to talk about case studies in reference to all of the principles that we put together in Pretty Good House. Yes, technically it is a book. Yes, there is a lot more information than you'll get in this short webinar that Mike and I are doing, with the website and the course. There's so many different ways to learn more about it. But the case study is one way that I like to talk about what I've done in some of my projects to make them a pretty good house. So this first one is the Slate Farmhouse. And I want to talk a little bit about economics first. And the first thing is that it's a very square building. So unlike the slide where Mike was talking about design, where there are 15 different roof lines, the fewer roof lines you have, the easier it is to build, the easier it is to insulate, and the easier it is to continue to maintain all those air sealing details and the materials with it. This is a 3-bedroom, 2.5 bathroom house. I like to give exterior square footage because that is what the code department is going to use to determine what your taxes are going to be. Then we also put livable square footage in there. This is a double stud wall. So we have really thick R40 walls in this house. So we like to give people an idea of livable square footage. But as far as economics go, I start from the very beginning with my clients and I say, I don't care, what you think the number of square footage is that you need. Let's talk about your program, your family, and how you use your space. So economics is a lot on getting people to actually honestly answer the things that they need to be satisfied with their houses, because I don't know about you, but I've been doing this for a lot of years and I can't just lick my finger and go, yeah, this house is 1,800 square feet. So try to just throw square footage out from the very beginning. Keep those numbers low as a designer. That's our job, to give them everything they need, talk them through the things they don't need to make it. So this house doesn't have a formal dining room. It doesn't have a lot of extra, but one thing that it does have, and you can see kind of here on the left-hand side, is it has a first floor bedroom. So this is something in particular that I hear a lot of right now. And I said R40, but this was back when we were doing 2x10 walls. And so we actually have R32 in our walls, R60 in our roof structure. We have R23 in the basement. It has 3 mini splits, one on the first floor, one on the second floor, one on the in the basement. And the one in the basement is mostly for condensation resistance. They do have a wood stove, so you can ask me about that. If I had my ways, it would be no intentional indoor fires. But in Maine here, we have to talk about what we want to do for resiliency, and we lose power a lot. And so we don't want you to freeze. That would be a problem. One of the things that they did for economics was actually go with a double pane window. Since we have done this in this house, this was actually one of my GCs that I work with, and she wanted to give it a try and see if it would work. She said, all the other houses we built together since then with triple pane windows, I would have gone with a triple pane window. So I'll talk about that in a minute if it comes up. Part of what we wanted to do is have a really solid team. So the GC is a woman, the landscape architect is a woman, I am a woman, a female architect. That wasn't that important for overall, but it was really important in how we communicated with each other and how this project came together. We were all involved in the project the whole time. The landscape architect was involved from the very beginning. She did all of the water management, how you approach the house, so much more than just having beautiful gardens that are planted after the fact. And then the builder is actually really into design. So she was into a lot of it during the design process. And since I'm a HERS rater, I actually came and did all of the insulation inspections, all the blower door testing, and all of the air sealing inspections as well. So I'm involved during the whole process. And that's one thing that if you are a design professional in the audience, even if you get value engineered out of the project, still go to the job site. This is how I learn and grow better and get better at my details that I put together. An important tenet for Pretty Good House is site, and it's really important what is going on with the site. This particular site is actually on a 5-lot subdivision that we created. It was really harvested poorly, left a lot of slash, and they wanted to give back to the land. So this is a completely solar development. We tried to minimize the impact. We had the landscape architect involved with us so that we could bring biophilic design back in and do pollinator plants and a lot less grass. So we wanted to be really careful with what we were doing with the site, but it was also incredibly important the way that we oriented the houses. All of these houses aren't oriented straight onto the road where you pull into your garage and you go in your house and you never talk to anyone. They're all oriented to the south, which means half of the houses face to the front, half of the houses face to the back. And that has really been dependent on the clients that live in those houses. But you can do so much with the orientation of your house to improve the economics and the energy performance. And that doesn't cost you anything if you do it the first time. But, nowadays we're not going to pick up our houses and turn the orientation if we don't get it right the first time. So site planning is incredibly important, both for understanding the soils that you have, because the other challenge for this particular site was that they have really poorly draining clay soils. So we had to be really careful about how it drained, where it drained, and what we could grow on the site afterwards. Here's a little bit more of the site. You can see they scraped and then put back down the dirt that they have, because this is something that already grew in here. So this is a wildflower buffer before we started designing this house. They picked it up and they put it back down so these plants would grow again in the soil. This is sort of our simple compact rectangle. They try to make a rectangle that works pretty well. Up here in the Northeast, we try to have a lot more windows on the south side. As you can see, I have one window here on the north. We try to really cut down. If you're trying to save money on windows, I wouldn't do it by putting in double pane windows. I'd do it by putting in fewer windows in the places that you don't need them. We use our porches here. It's a 5-foot porch that allows us to minimize any solar that we would get in the summertime to heat the house and maximize the amount of sunlight we can get into the space in the wintertime. Here's our second floor compact above. We're trying to cut down on the amount of square footage. So we do have two simple roof shaves by adding that first floor bedroom onto this house. This particular homeowner also wanted to have the open loft space in here. This is a challenge, not just in pretty good houses, but in all houses. But the better you do in your insulation package, the less you're going to have temperature stratification and lose a lot of that heat to the upper level of your house, except for when you're running your wood stove. So here's a picture of the wood stove, the double height space. Most of these timbers are salvaged from a local place here in Maine, and they were scribed to the ceiling. Mike mentioned in the beginning about talking about designs that you have to love it. So they wanted to really love this space. They wanted to feel like they lived in an old barn, but they wanted to live in a space that was really comfortable to live in, heat and cool. I think with the solar panels on the roof, it only costs her maybe $11 to $30 a month to live in this house for everything, all included. But materials were really important, which is to give these materials a second life, both for their carbon impact. If we're not letting it decay into the earth, we're carbon storing it, but also vintage materials really add a lot of life to the inside of what is a new house. Aside from materials, we also want to talk a lot about fenestration. I mentioned to you that the windows on this particular house were double hung, double pane, and she regrets that decision. This beautiful window here is 9 feet wide. They have double waffle shades that they have to pull down every night because they give off too much heat to this particular window, and it's pretty chilly and cool to hang out in this space. So as far as pretty good house goes, when you're looking at economics, you want to try to choose the economics to change your project by changing your design and not by giving up on anything that you would do as far as performance goes. Now, the waffle shades do make a difference, but the triple pane window may never pay for itself. Windows never pay for themselves. They're always incredibly expensive. However, they're good for about 5 to 7 degrees of temperature, which that radiation inside the structure where you're giving heat to that cold window on a winter day is really incredibly important. So if she had it to do over again, she would change this. She would put in triple pane windows. It was something we wanted to try. What can we do with builder grade materials and still get to a pretty good house? It sacrifices a little bit of performance, but it sacrifices more comfort than we expected. Another thing that I'll point out, which isn't on this slide, but somebody posted it in the chat box, and I don't know if I thoroughly answered your question, but the reason why I asked if you had shingles that were holding the snow up and keeping the panels from losing their snow, you can see here, we left a space for a third row of panels. If they ever decided to add an electric car or do something else with this house, we left space for a third row of panels. But what we didn't think about in our interim of that was that the shingles, the asphalt shingles, actually hold the snow on the roof, which holds the snow onto our panels. So if we had a snow slide here at the bottom, the snow would slide off. If we had a third row of panels, the panels themselves would clear off a little bit better. So yeah, that was something that we didn't anticipate. We were really planning for resiliency, planning for the future. And unfortunately, it had an unanticipated consequence that we now know and try to plan better for. Again, with thermal performance, Mike talked a little bit about this, but you have you have your ratings based on the type of windows that you have. European windows and American windows aren't rated the same way. Some of them are just center of glass U values or U factors. Some of them are the whole window performance, which is why when you see the triple pane European windows, they have a much thicker overall profile to the window because they do a lot more with how their windows are put together. So these are just some windows as we were putting in. We do a lot of sheetrock returns. That's an area where we try to cut down on materials and try to cut down on costs. We would not do a sheetrock return on the bottom of the window. We did that once. That's a really great way for the sheetrock to get damaged on the bottom of the window. This house was panelized. So what we did was actually just open framing panelization. They put most of our exterior fully adhered WRB on in the factory. They came back and they overlapped all of the seams here to make sure that they had a fully adhered membrane on the exterior. This is actually how we get our air barrier in this system. It's a double stud wall. And this is great because it can go up in a couple of days, which is pretty impressive. It can be built in a shop. There's a lot more control over it. You can get panelization anywhere from just open framing all the way through walls, windows, doors installed, already insulated, ready to go in, ready for electrical. And I've done it a bunch of different ways. What's great about panelization in the factory is the control that they have over it. What's not great about it is they have a lot of cost and overhead. So unfortunately, it's not always a cheaper option. This is our quick profile of this. We have scissor trusses. This is partially because one of the things that we try to do with our structures is make them look proportionally correct, which as you get to high heels on your trusses or full stories on the second floor, you end up getting a really tall building, which starts to look kind of uncomfortable with proportions. So we've gotten creative with our proportions, shorter walls, vaulted ceilings on the second floor, which add character, but also allow us to keep an exterior proportion that works. You can see here our double stud wall separated on the bottom side. Interior 2x4, exterior 2x4, depending on where you are, will depend on whether or not the exterior needs to be 2x6. Also can depend on whether or not you can get a straight 2x4, which is a complaint that we get a lot from our contractors. More framing here. You can see we've got what we've got going on, and then we've got rigid insulation on our basement foundation system. This is everything taped and sealed, but one of the things that we want to see in this is what we're doing for HVAC. Now, this particular house does not have an ERV. It has a continuous exhaust-only ventilation system. The tighter you build your house, the less likely this scenario will work. This has a blower door of 1.5, and it actually has a passive air intake that the homeowner is very active and opens. You can have a passive house and active occupants, or you can have an active house and passive occupants. I don't think that you can have all passive. You really have to have an active occupant, which they happen to be. It goes through the basement. It preheats from the basement. They open the ventilation when they need to use their dryer, when they use their range vent hood, when they have anything more than, a continuous 15 CFM pulling. Indoor air quality is incredibly important. That's one of the things we talk a lot about with pretty good houses. Indoor occupant health is become incredibly important. This is a ductless mini split. For those who don't know, the great part about ductless mini splits is it really cuts down on the utility spaces, because if you've heard me talk at all, I'm not really pro basement. This particular house has a basement, but I hate basements. I want to cut down on concrete, want to cut down on a lot of stuff. So ductless mini splits help that to happen. Our preference is one indoor head for one outdoor compressor for a number of reasons. One of those being if one goes down, you still have another one operating. The other is if you happen to have a larger compressor with 3 heads on the inside, you'll never get down to the efficiency of the system, because you could have one head that's asking for heating or cooling while the rest of them are not. So you're not taking advantage of the efficiency of the system. And the third is if we can cut down on the amount of line sets running through our house, we can cut down on any time if we have a particular issue, because the refrigerant isn't the nicest thing for the environment either. So we definitely want to minimize any chances for refrigerant leaks. Energy, we want a pretty good house to be set up to be solar ready, even if you can't, if that's something that works in your area, depending on where you guys are. I know I saw there are people from outside the United States. There are people from all different states on here. Solar isn't always easily or readily accessible in areas, but we try to up here in Maine, and we have a really strong solar program. So we try to make all of our houses solar ready, so that they can add energy production on there, trying to get towards clean energy sources and all electric houses, but producing the electricity we need, because our grid system isn't quite ready to handle everybody having all electric houses and all electric vehicles. This is an interior picture, again, with a lot more salvage. This homeowner was into really a lot of salvaged materials. This is actually a very old slate sink that they had refurbished. They used old barn wood to create the hood. So really to add character, but also to repurpose materials that would otherwise go to the landfill. Again, more barn boards. Now, this is where it starts to get expensive, and you have to have somebody, either yourself, the homeowner, who is willing to pay for this. They had to pull out all the nails out of the wood that they used on this particular material, and you want to know what's in your material. So salvage materials are great because they often have off-gassed. However, older materials tend to have stuff in them that is less great for your indoor air quality. So just be really careful about the materials that you choose to use inside in your house. Some other creative ideas that we've come up with. We wanted to make sure that our overhang on our farmer's porch was short enough that we could take advantage of as much sunlight in the wintertime as possible. But that meant that the extension of our porch needed to be longer. They wanted a wider porch. So we came up with this creative solution to add a grate into the porch so the water runs off the roof into the grate and down to the subsurface water and drainage below it, to try to keep from having to have materials that needed to be constantly replaced. On the left-hand side here, you can see reclaimed bricks that they pulled in. The challenge with reclaimed bricks, and if you have homeowners that want to do that, is if you use a full brick, you need to drop the floor to make sure that this fits in here flush. So those are just things you need to think about during the design process if you have things that are interesting or challenging. I do energy modeling on all of my projects. This is Ecotrope. So this output here is from Ecotrope as a HERS rater. That's what I use to evaluate it. And the homeowner verified. So we had it estimated that their energy bills would be around $800 a year. It turns out they're around $815. She has when we started talking about this, she has 2 teenagers that live at home, which is why this number is slightly higher than it might have been. We planned for having 2 teenagers. When we built the first house, I think it cost her $11 a month to live in it because she had 2 very young kids. So anyway, we do a whole energy model. We tried to get the general BTU loads for our heating and cooling so that we can use that as a comparison to what we get back from Manual J from our mechanical contractors. But also, if we don't have a target that we're working towards, how do we know if we were successful at building a pretty good house? So Mike was talking about verification. I like to do a lot of verification on my projects just so I know what I'm working with. And then the very last thing that I do with all of my homeowners is an owner's manual and a walkthrough at the end of the project. And then I usually try to follow up with them about a month after the project is finished because they're just ready to move in. They're ready for the contractor to be gone. And then they move into a house that has systems that they don't know how to use. And you try to do a full walkthrough, explain to them how to use the ERV, how to use the heat pump, how to use everything in the house. But it's been a long process of building and they don't remember. So we usually follow up with them about a month after they've moved in just to go over all the systems, make sure they understand it. I had a client call me once and say, I think I'm breaking all of your rules. I don't understand this. And so I went over and said, you're not breaking any of my rules. Here's what you need to understand. And they thought the thermostat was in the remote control for the ductless mini split. So they were moving around trying to put it in the sun to see if they could change the temperature inside the house. So again, it's really important. Somebody asked me once if I'd put an indoor air quality monitor in my house. I put it in every single one. I prefer my clients call me when they think they have an issue. It doesn't matter what the numbers say, just when it spikes. I want them to call us and say, I think I'm having an issue with the house. We actually caught a dryer vent that wasn't connected that way, and that can be, a really unhealthy situation for people. So owner and occupant behavior is to really help them to understand, because do you really have a pretty good house if the owner doesn't know how to live in it and operate it after? So this is the final slide, Mike's contact and my contact. So Mike, if you want to come back on, I know I rushed through that. I wanted to make sure we left enough time to hopefully answer your questions, both on Pretty Good House or if people have specific questions about this house.
Hey, great. Thank you for that, Emily and Mike as well. And yeah, we have tons of questions coming in. I know a lot of you got to them as we were going, but I do want to bring a few up and highlight a few that I think are worth talking about. And we definitely still have some more time to stick around and answer some other questions as you have them. Before we get to those questions, just a real quick reminder, real quick, as a reminder, this session will be recorded, posted up on our YouTube channel. You can rewatch it, share it, send it to a colleague, a friend, put it on social media, whatever you like. And you can go there and subscribe right now and check that out, and you'll get an instant update when it is available. And then also, for those of you watching this in the future, not right now, on demand on our channel, go ahead and take the quiz with an 80% passing rate, and you will receive your CEUS certificate. For those of you who are here right now, hopefully you've been here for a majority of the time. And as long as you're appropriately logged in Zoom and got the name you want printed on your certificates, you can check your spam certs at gutenbergcerts.com. You will receive your certificate here in the next couple of days. And again, before we get into all those questions coming in, a huge thanks to our board of directors, all of our volunteers, our executive director, Jose Reyna, nearly 300 members now help us get there, and all of our top tier sponsors, Mitsubishi, April Air, they're all going to help you build pretty good houses or better. So they're there to help you, and they're going to make it happen. So there were a lot of questions that were coming in about the the energy rating pathways, sort of, in the energy modeling pathways. And I think we started talking a little bit about those as well. And I saw some of the comments come through in the chat. But I mean, let's just kind of talk about, those tools again, and what you recommend, people to use.
Yes. Sorry. Was that a question directed to me? Because I can't answer the chat and answer questions.
Yeah, sorry,
I'd say at this point now, just the chat's good. And why don't we talk? So.
Okay. Sorry. Yeah, I was absorbed in the chat too. You were.
So
yeah, can you replay?
Yeah, I was just going back to the energy modeling, and I'll, you keep mentioning ecotrope, but of course, ecotrope is of itself, it is just a means to an end, right? So, right, it's for a HERS rating, right? A HERS index rating, which, as far as I know, is the dominant energy rating software across at least the United States. And I think other countries are asking to use it because we've been finding they don't have it. For those of you who are tuning in from other countries, or they don't have anything. Even in Europe, we get surprised. So, I mean, what are you recommending? Should we be using things like Woofy and Passive House Planning Package? Is that going to be giving you better information? Is that too much? And what about those with the existing homes? What are they looking at?
Sure. I do find, so as a HERS rater, I do use Ecotrope, and you can use it for ratings, but I also find that it's a really good tool to use as a comparison. So if you're just trying to figure out some economics on changing something out, or changing the orientation, or getting rid of a window, you can get a lot of valuable information out of it. I'd never use it to size a heating system. And I think I posted in the Q&A session a bunch of different energy modeling. One of them is one that Mike uses to do HVAC, so you can understand more about your HVAC design. I think that if you're concerned about moisture, you might want to do something like Woofy. I think Woofy, unlike PHPP, right? So if you're passive house people, whether you're PHI or FEIS, unlike PHPP, which I think is a very complicated spreadsheet analysis tool, Woofy can give you good information that you can use on the appraisal addendum as well. It can give you overall, and if you're concerned about moisture in your wall systems, right? So if you think you're building a risky wall system, now this is all energy modeling is based on conditions. Does it mean it will happen? Not necessarily, but if you want to be or if you want to be more risk averse, it's a great place to start. If you're doing an existing house, I still think that you can use Ecotrope to do that, or other systems where you can kind of evaluate. So if you're doing a an energy efficient mortgage, right? So if you're going to try to get an energy efficient mortgage to do renovation work on a particular property, they often use rating software to do that. So you can put an existing house in and you can compare it to the energy improvements that you're going to do to see if the improvements that you want to make will cut down on the amount that you'll spend in utility bills. And I'll tell you from the very beginning, if you want to put new windows in, the answer is nope. It's not happening. Don't do it. Last thing, won't pay for itself. But if you're trying to make some decisions about whether or not, adding R60 blown in insulation to the attic makes sense and you can finance that through your mortgage, you can use that as a tool. BOPT is free for anybody who has a PC. So if you're just trying to get into it, I think all energy modeling is what you put in is what you get out of it. So the more detailed it is, the more information you can get out of it, but you can also skew the system. So the better you are at doing it and understanding what the output is. So actually in the course that Mike talked about that I just did, I'm do a segment on doing longhand heating calculations, heat loss calculations. So if you just need to understand the basics of what might be behind it, we do a little bit of that in the course. So not too much math, but a little bit of math.
Yeah, and you're an energy rater, you're an architect, but what do you say to those architects? Because I've always encouraged architects to get familiar with the energy software in some regards, because they almost sometimes have to fact check the energy raters, right? I hate to say that's sort of the worst reason you want to do it, but
right.
Just pretending you're not an energy rater, and it's hard to do that, but what can you say to the architects to not be afraid to use these tools? Is it available to them if they're not certified raters?
Yes. And I think Ecotrope has a version, although I think you have to reach out to Ecotrope, that is non-rated version that you could use. RemRate is the other software that's used by raters, and they have a version called Rem Design that you can use. Personally, I think Rem Design is a little clunkier. So for all of my more astute architects out there, those of you who use Revit or other programs that you feel really confident in, I think Revit is trying to make a plugin for this. I know Ted Benson has been talking about creating a platform that has some of these things built into it. I think we should be pushing for it because there shouldn't be any reason why these two things can't plug in together so that it can pull the information out of the work that you've already done and put it into a model. But it really is just data entry. So don't be afraid of it. It's just a lot of data entry. And so you should be able to pull that information from your drawings, whether you're the contractor, whether you're the builder, and just plug the data entry in. So if you have to, have someone on your staff do it for you, just give them all the information they need. And then you can start evaluating it and looking at it and changing things to see what makes the most sense.
Yeah. Or if I could just add quickly, this has come up recently. Often people will ask us, or architects will ask us to come in at the end of the project after they've designed the house, if we can sprinkle a little pretty good house magic on it and make the house pretty good. And it's just, I think designers and architects would really, really benefit from learning any energy modeling program. It's almost less important which one it is because they're all based on similar underlying math. But just understand so they understand the impact of the things they're doing. If they love, giant windows, great. So put them in at the beginning so they can see what that's doing to the energy performance.
Well, and that kind of gets into my segues into the next question a little bit. And so we sort of have a model here where we say, why guess when you can know? And so the energy modeling side, or anything, the materials you want to use, solar, using passive solar, using water conservation, hitting indoor air quality targets, right? Or embodied carbon targets. Like you said, someone calls you after it's already designed, and then you try to slam it in there. Or maybe worse, they try to call you when it's already built, and they're like, what did we do here? So what kind of advice can you say, or what is built into the Pretty Good House philosophy to encourage people, because what happens is, someone's like, we put green, we stamped green, it was going to be green in the specs, right? And then we get to the end of the project and all this stuff is just missing. The energy models don't come to fruition. And we're just like, well, let's go back to the start. Where did that conversation come in? How did you have it? Did you not have it? Did you do any modeling? Did you spec this stuff and then make sure it got ordered? So what I'm getting at is this part of Pretty Good House to make sure that there's some sort of way to encourage people that they're really thinking about all this at the beginning and that it goes through to the end?
I think
Oh, go ahead.
Pretty Good House is really meant to be a house as a system concept, which means that you do have to think about it from the very beginning. The more you do it and the more you understand it, the easier it is to think about it from the whole, from the beginning to the end. It's part of why we put together the book. So, this was a really broad overview, but kind of like the prescriptive versus UA parts of the code, right? It's like, if you don't have time to do all of it, at least look at the things like, okay, I need to hit this target or this value or this, whatever. Your clients are often going to dictate a lot of things to you. Maybe it's because I've been talking about it for a long time that we have clients that come to us that say, hey, I have, chemical sensitivities. Can we do more with materials? Right. So that's going to help to dictate what you do in your buildings. But just like the BEAM calculator, once you've put your project through BEAM once or twice, you're going to know which products and materials make a biggest impact, and you can start building that into it. So I would say Pretty Good House is really meant to be like a start somewhere, make improvements like as you go along, right? You don't want to get to the end of the project and be like, well, none of this happened. That is definitely not our goal. It really is a whole house as a system approach. And so, for me, I think that it just, even if you don't do an energy model, if you knew a lot of these things, that when you get to the end, you're doing pretty well.
There's some wait, sorry, Mike, did you have anything to add into that?
Oh, yeah, just phrased a different way. Basically, it would be great if every house met building challenge principles, because those are the truly sustainable homes. And in 20 years, I think there's like 3 of them in the US. So it's just, there's a big gap between what we're doing on average and what we all should really be doing. And so every project is a compromise. And so it's okay if everything is not perfect in every project. Try to do one more thing. And the book is more about things to think about and how to think about them, rather than saying, do this, do that. Like, we make a pitch for not using excess concrete and excess foam. If you read the book and decide that you need a house built out of concrete and foam because it makes sense for you, but you introduce something new, like doing an energy model or getting a HERS rating or using a mini split or whatever it is, as long as you're trying to improve with each project, that's our goal, is to try to move the needle across the board, rather than trying to just make everybody build these perfect houses that nobody can afford.
Yeah. So you got this, this training coming up, and their question here is sort of, how do I identify pretty good house builders, right? How do I hire them? Is there any intent to have a training or listing, or is it just kind of a case study approach, or how do you answer that question?
It's a tough one, because we don't have a central verifying body taking money and issuing certificates and training. There's really no Pretty Good House qualified designers and builders, and anybody can say they are one. So it's we've had lots of people ask us to put up a list, and just we haven't figured a way to do it that wouldn't let just everybody on. So I mean, things like GHI probably has a members list. Passive House, CEUS have member lists, lead. Those I think are good places to start, but it's really more about networking. I think find somebody who has built the kind of house you want to build, and find out who was on their team.
Let's talk about the house that you wanted to build, because I noticed a little bit of maybe this is just me, maybe there's a way to explain this, but a little bit of tension here between something you said at the beginning, Mike, and then something you kind of ended with, Emily, where Mike, you had said you don't want to necessarily just build a house that's for you, because then someone's going to come and tear it down, and that's bad for the environment. So I'm just imagining like someone going and buying this house and, oh, it's an ugly house, let's knock the whole thing down, like and perhaps maybe the cost of building housing will prevent that. But then we get to the end of your presentation and we start talking about the house that's perfect for the client. But then that kind of went back to that further thought where you said, well, what if it's just such a weird house, someone's going to knock it down? So I guess, can you tell me like how much thought someone should be putting into building the house for the individual right then versus someone who's going to be using it in the future? And how do you really draw that line?
Well, it's hard to draw that line because, in our opinion, if you're going to stay there for more than 5 years, you should build the house you want to build and not build what the market tells you should build. So it's kind of like a 3-part thing, right? The average house in the United States is 2,500 square feet. And we're trying to get people to understand that that is just a market condition for a number of reasons. One, when you build a really high performance house that is comfortable, healthy, durable, people have a tendency to stick around longer, which means that the market doesn't have anything to compare it to. So what gets sold over and over and over again is 2,500 square feet. But people come to us all the time saying, I don't want 2,500 square feet. I'm trying to downsize. I'm trying to, do all of these things. So in some ways you want to build a house that's appropriate for them, but that doesn't mean that it isn't appropriate for future people either, right? Because there's also other people out there who also want 800 square feet, right? So you're trying to throw out this whole, everybody in the market wants the same thing. At the same time, if we really wanted to make a vast improvement on housing, we would get developers to build better housing and it would be the same house over and over and over again. So that would have a much bigger, most of the housing built in the United States isn't done by an architect, isn't done by somebody who's trying to do, passive house, pretty good house, whatever. It is built by developers who are building what sells, right? Or what they think sells, or what's the cheapest way to get rid of a tract of land or property. But in the same time, when we say really weird, really funky, I don't know if we have any control over that, because somebody might love something that's really funky, right? But if you build it on the ocean, somebody might just want to come and have your ocean property and hate the house that you built. So there isn't a lot of control. And one of the beautiful things about architecture is there are so many different styles, right? There's modern and there are people who hate modern architecture. There's traditional and there are people who hate traditional architecture. So it's a really hard thing to kind of balance when, you're talking about people need to love it.
Yeah, fair enough. I want to talk a little bit about ventilation. I may have missed some of it. We talked actually quite a bit about air quality monitoring, which I think is great. A conversation that we need to be having that gets missed so often. And then I remember seeing a picture of a hood range, right? And I saw a picture of a bath fan. But what about, recovery ventilation, balanced ventilation, smart ventilation? And, I saw your mini splits and I started thinking, we've got humidity problems now on our hands, right? So talk to me a little bit about where ventilation and humidity control might be in pretty good house, or maybe if I missed something, I guess just reiterate it.
Yeah, go ahead, Mike.
I think in the mechanical discussion, I should have mentioned that when we first came up with this idea or brainstorm things, the idea of any ventilation was pretty new. So we just wanted exhaust only ventilation would be okay. Now we really prefer balanced ventilation just because it is possible to depressurize the interior, which can have lots of different effects. Balanced ventilation it's expensive, but just we think indoor air quality is worth it. So generally we like ventilating to ASHRAE 62.2, 20, and whatever the latest 2016 standard, or passive house, which is pretty similar. And then we do prefer all electric interiors, which by code does not require a range hood, but we still strongly prefer having a range hood that vents to the outdoors, even if you have an induction cooktop, because it's not just burning the fossil fuels that creates bad stuff. Actually, the worst thing that that's created when you cook is the PM 2.5 particles that when you inhale them, they go through your lungs directly into your bloodstream. They're so small. So just you really want to get those particulates out as quickly as possible, get any moisture generated out as quickly as possible. We do hate the term houses have to breathe. The fact is houses do not have to breathe. People have to breathe. Houses need to dry. And so, but there is a sort houses like things as dry as possible. The dry the better. People do best at between about 20% and 60% humidity. Viruses do well at the lower end of that. So to balance everything, we recommend staying between about 40 and 60% humidity, but 60 is getting on the high end. So really, if you can target 40 to 50%, that's sort of ideal across the board. It's hard to hit that perfectly, but that's a good goal. Would you agree, Emily?
I would 100% agree. And I would agree with whoever just posted it in the chat. Balanced ventilation is not that expensive. We need to stop saying that it's, I mean, yes, the system itself as an individual thing is expensive, right? But it's like 1% of the house build when you start thinking about all the other things that are in it. And so we agree that houses don't need to breathe, that the occupants need to breathe, and that we're building these high performance houses. And so we need to deal with that. We have tried exhaust only ventilation, and the tighter you build the house, the harder that is to accomplish. And then we're asking our materials to handle moisture that they shouldn't have to otherwise handle. So I personally put ERVs in all of my projects, and that's a non-negotiable. So that's another thing for Pretty Good House. People often ask me about business things is start just setting a minimum standard for yourself as a business, as this is our minimum standard of what we'll do or what we'll provide for our homeowners. Because we've tried it in other ways, and like all good builders and designers and architects, you got to try everything till you figure out what works. And so then, you do that. Balanced ventilation. The struggle that I have with balanced ventilation is that the only person that does full-time commissioning on their systems is Zender, which is the most expensive one that you can put in. But it is the most expensive because they do come out and they do commission their systems, and they make sure that you're getting the proper ventilation where you need it. So this is where it comes back to HERS raters or somebody third-party verification. If you put mechanical systems in, it is important for you to test out your mechanical systems, and not just at the unit that the same amount of air is coming in is going out, but that the air that you're expecting to either be exhausted from or supplied to a certain area is correct. And for us, humidity isn't as big of an issue yet. We're starting to see it in shoulder seasons. Zender and Santa Fe got together and they started adding a dehumidifier to the system, which is awesome. So for all of you Zender people out there, you can get a dehumidifier that's part of your ERV system, which will probably make all of our Southern people happy, because ERVs and HRVs are set to wintertime conditions. So in humid climates, that is a problem and something that people should be aware of, because you don't want to run it more in the summertime when you have high humidity. Unfortunately, dehumidification, I think, is becoming an issue for those of us who are in more heating dominated climates, but starting to see air conditioning. Our air conditioning in a high performance house in a heating dominated climate may not run long enough to dehumidify the space. For people in cooling climates, your air conditioning may run long enough because it needs to do it to keep up. So dehumidification plus ventilation is becoming more of a thing in shoulder seasons or really high performance houses, if that answers more.
Yeah, and that's really great to hear, because I've heard of ventilating dehumidifiers, but now you're saying there's ventilating dehumidifiers with recovery. Is that, yeah? So
essentially, Santa Fe dehumidifier is in line with the Zender ERV.
Oh, so you still got two units.
You still have
And they're just
technically
like,
two units that are paired
okay.
together, so you can run it through the same. So it basically
Right,
makes your dehumidification ventilated.
right,
That-
right. Yeah.
So,
Very interesting. But cool to, definitely cool to hear. So, and yeah, absolutely. A lot of people still installing oversized AC around here. But I will tell you, when it is right sized, it runs all day in those heat waves. So,
right.
yeah. So, there's a lot of, still some, there's a question in here about, you had Emily, you mentioned that, how do you recommend against a loft area, the large west window, et cetera? Would you summarize the ideal for this model performance wise versus the built model? Would it have saved the mini splits, for example?
It doesn't save so much on the mini splits in that area as it does on the comfort for the homeowner. So the homeowner at night has to put the curtains down, or they feel really cold in that space. So if they don't close the curtains on that and really create a buffer between them and the windows, then they're going to have to turn up the heating system. So yes, I guess in an effect, they may have to run their heat or their wood stove at a higher level to be comfortable in the same space because it's cold. Does that make sense?
Does to me. We'll see if they can respond back. If it doesn't. So,
Okay.
there was some questions in here on using energy modeling for passive solar. Have you found that to be helpful at all, or are you just making more prescriptive approaches, or both?
I do both, and I didn't teach it in the class, so I apologize for anyone who wants to know how to do that. But I teach it in my university class. You can use that. There are other tools out there that help with that for passive solar. I really do. I think that some of the energy modeling programs are better at anticipating it if you have to put in the solar heat gain coefficient. Unfortunately, a lot of US window manufacturers have really low solar heat gain coefficients. So you got to be careful with your windows. So if you're putting it into your energy model and being really clear about what the solar heat gain coefficient is on your window on that side of the house and the shading devices, you can get some of that information out of the model itself. You can do longhand with daylight factor and solar heat gain coefficient and how much thermal mass that you need to have in order to make that work. So there are ways to do it. We don't always go to that extent. Because again, this is going back between, the amount of time and energy that your clients will pay you for to do certain things, and then just good practice over a certain amount of time. So.
Oh yeah, and also, I mean, I think in general, this is a conversation that comes up a lot in high performance design, or specifically passive house design. People confuse passive solar experiments of the 1970s and 80s and want us with what we now know is usually the easiest path to high performance. So we don't want to overglaze. We aren't trying to build sun spaces with fans that feed trome walls and those kinds of things. Those all can work, but we're sort of trying to steer people towards more conventional looking houses that have good insulation, good air sealing, windows that let in some heat, but not all the heat, for a lower across the board load for heating and cooling, if that makes sense.
Want to ask a question, and besides the acronym problem here, what if people want to actually do better than a pretty good house and build a pretty great house, or build the greatest house or the best house? What are your suggestions? Are you thinking about sort of a phase 2, right, or a step 2? We talked a lot about a tiered approach.
Yeah. Well, I think we should I should have mentioned initially. I think a lot of people misunderstand the term "pretty good house." You kind of have to understand the New England sort of cynical sense of humor, and particularly Dan Colbert, our moderator, is from New York, and so he has an extra cynical sense of humor. And so it's really, you can think about it as the pretty darn good house, pretty damn good house, the really good house, whatever you want. And it's really just, you can have a passive house that's also a pretty good house, because passive house doesn't care about things like where the materials came from, or what's heating the house, or all of the other things we think are important. It cares about air changes per hour and insulation levels, basically. So we love passive house, but it's narrowly defined. So as long as you're going above code minimum to whatever level makes sense for you, you can have a pretty good house anywhere up to and beyond passive house.
Yeah, and the only other thing that I would add to that is pretty good house wants you to look at things that aren't maybe involved in every certification project, except for maybe Living Building Challenge. I don't know. So if you want to build like the very, very best one, go there, take a look, do red lists, do all the things. But that you could apply the principles to any of these certification programs and look at Pretty Good House and say, I'm going to do carbon, and I'm going to do, a great design, and I'm going to meet all of Passive House's requirements. And I'm going to do, I don't know what all of your checklists are, but, maybe I'm doing a GHI house. And I'm going to meet all of them, plus these extra things if I'm going to build the best house in the world. Pretty Good House isn't meant to be mutually exclusive from any of these. You could have a pretty good GHI house.
Yeah, great. Well, we are at our time here, and any other questions, we'll pass those on to you all. But Mike, Emily, I really appreciate your time and for helping us kick off the new year and going through a lot of sharing your knowledge. And everybody, encourage you to pick up the book and check out the Sustainable Accelerator as well. But otherwise, where can people go to learn more about what you all are doing, the Pretty Good House, and contact you for more information?
For me, it's just mains.design, or go to Green Building Advisor. If you have questions, I get a lot of direct questions emailed, and I end up directing people to GBA. So GBA is a good place to ask questions. Mains Design, if you want to work with me, and Emily is marshallmarch.com.
Yeah, I actually think on Green Building Advisor, there is a Pretty Good House section if you want to ask a question. So your question may have already been answered, but Pretty Good House will probably pop it back to one of us or one of the other authors to answer the question if it hasn't previously been answered. You can find all of our BS and Beer show on YouTube. So all of the past episodes, we did it once a week for 2 years. So there's quite a lot of information. So if you weren't quite sure what Mike was saying about kitchen ventilation, go watch Ross Trethewey. You'll never cook in your kitchen ever again. It's great. But lots of great information there. We are live once a month on Thursday nights. I think it's going to be January 13th for BS and Beer. So Mike and I will probably both be on that. You can find my podcast is up on all the normal podcast things. You Google us, you'll find us.
All right. Emily, Mike, thank you so much for your time. Thank you all for joining us. Take care, and we'll see you all next week. Bye.
Awesome. Thanks.
Thank you.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.